its converse statement is if each pair of co-interior angles, if each pair of co-interior angles or each pair of co-exterior angles, each pair of co-exterior angles forms a supplementary angle, then the given lines are parallel. Okay, once say that what is the converse statement? That is, if that co-interior angles, each pair of co-interior angles or each pair of co-exterior angles forms a supplementary angle, then that given lines are parallel. Okay, previous condition what they are saying, if the transversal cuts the two parallel lines, okay, then that each pair of co-interior angles forms supplementary and each pair of co-exterior angles also forms supplementary. Okay, to that statement what is the converse statement? Here they are not saying that given lines are parallel or intersecting. Okay, just we have to say that by using that given angles. So here we have to check that angle 3 and angle 6 and angle 4 and angle 5. Okay, those pairs forms supplementary or not. And in the same way, angle 1 and angle 8, angle 2 and angle 7. Okay, those angles, each pair forms a supplementary or not. If they forms that supplementary, then easily we can say that given lines are parallel. So here converse statement also true. Okay. So here another condition is some other important conditions. If two parallel lines parallel to that other parallel line, okay, if two parallel lines parallel to that another line, then here we can say that each line is parallel to each other. Okay, then all the lines are parallel to each other. Okay, for example here L is parallel to M, already given. Now here M is parallel to N. Okay, then we can say that just like that here L is parallel to M and another one is M is parallel to N. Okay, if two parallel lines are parallel to that another line, okay, if two lines are parallel to that another line, then here we can say that each line is parallel to other, which means all lines are parallel to each other. So from this condition we can write that here L is parallel to M, M is parallel to N. Right? So here we can say that L is parallel to M is parallel to N. So here three lines also parallel to each other. Okay, so from this condition what we can say? Here L is parallel to M is parallel to M. Here L is parallel to M is parallel to N and P is a transversal. And P is a transversal. Okay, when it is possible, if that L is parallel to M and M is parallel to N, then only L is parallel to M is parallel to N. Okay, so what is that? Here L is parallel to M and M is parallel to N. Okay, that is the meaning of this first point. Okay, come to that second one. Okay, so what is that condition? If a transversal cuts three parallel lines, then their intercepts are equal. Okay, so here if a transversal cuts three parallel lines, then their intercepts are equal. Here intercepts means what? A transversal which cuts three lines at three distinct points, right? So here the first point I am going to take it as A, and the second one B, and this is C. So intercepts means what? The distance between two distinct points on a transversal. Okay, the distance between two distinct points on a transversal. So on this transversal, the distance between two points, the distance between two distinct points on a transversal only, no? Okay, so that is called here intercept. Okay, so actually condition what they are saying here, if a transversal cuts three parallel lines, then their intercepts are equal, which means AB intercept AB is equals to BC. Okay, they are saying that if the given lines are parallel, then the distance of that intercepts, which means the intercepts are equal. Okay, and it's a converse also true only. If that intercepts, okay, if that intercepts are equal, then we can say that given lines are parallel. Okay, so here converse also possible. Okay, see that next point. Okay, once see the conditions. If the transversal cuts two parallel lines, if a transversal cuts two parallel lines, which means here they are only saying that L is parallel to M and the transversal is N is a transversal, right? Okay, so here the bisectors of corresponding angles also parallel. Bisectors means what here? Angular bisectors. Bisectors is nothing but angular bisectors, right? Which divides one of the angle into two equal parts. Then we will call that one as angular bisector. Okay, so here EF is that angular bisector and AB is that another angular bisector. So once observe that here one of the angle is there, right? Here one of the angle is there, here one of the angle is there. So when you observe those two are corresponding angles only, no? Okay, so those two are that angular bisectors of that one pair of corresponding angles. Okay, so here what is that condition they are saying? If that given lines are parallel, then each pair of corresponding angles, its bisectors are parallel. Okay, which means here if L is parallel to M, if L is parallel to M, then what are that bisectors here? Then EF is parallel to AB. Okay, they are saying that EF is parallel to AB. Why? Because these two are angular bisectors now here. Okay, so EF is parallel to AB. When it is possible, if L is parallel to M, which means given lines are parallel, then only angular bisectors or the bisectors of each pair of corresponding angles are parallel. Okay, and it's a converse statement. Once say that if this is for that the first condition, here from that the second condition, if angular bisectors, if that each pair of angular bisectors are parallel, then the given lines are parallel. Okay, that's opposite converse. Okay, so what is that? The first condition is if the given lines are parallel, then it's angular bisectors of each pair of corresponding angles are parallel. Okay, come to that second statement. Here if each pair of angular bisectors of corresponding angles are parallel, then the given lines are parallel. Okay, those two statements are also true here. Okay, now come to that another one. Okay, once observe that those two statements, what is that? If a transversal cuts that two parallel lines, if a transversal cuts that two parallel lines, then the bisectors of alternate angles are also parallel. Okay, so if that condition L is a parallel to M condition they given, okay, then we can say that the bisectors of that alternate angles, the bisectors of that alternate angles are also parallel. Okay, that is that first condition, and it's a converse. What is that? If that bisectors of each pair of alternate angles are parallel, then we can say that given lines are parallel. Okay, so this is about that, these 2 points. Okay, so up to here completely elementary geometry completed. Okay, so next theory part completed. So after this one we will discuss worksheet problems. Okay, so in that worksheet problems we will learn deeply in that how to solve that problems. Okay, and how to find that each angle, we will learn that one neatly. Okay.